This is a double-decker bus from the 70s, and we're putting the equivalent of 5 Teslas worth of batteries in it to convert it to an electric house on wheels.
The result is this: 3,000 Newton meters of instant torque and a vehicle that's ready to take the owner across the countryside completely off grid.
All you have to do is turn on the key, put it into drive, and we're off to the races. This is our new electric vehicle conversion we're doing. It's a 1978 Leyland Atlantean. We've got our powertrains here. This is the old and the new. It went from about 1.5 tons down to 200 kilos, and we've doubled the power from 100 kilowatts to 220. Here we have our 1978 Leyland Atlantean that's been converted to electric. The original compressor used to run off the engine to supply air for the brakes. Once we converted it, we had to install a high voltage compressor to replace the old compressor. We'll head up the front now, turn on the bus and show how it works. The compressor's turning on.
This is just a video explaining how the dash works in our 70s double-decker bus EV conversion. So the driver starts by putting the key in the on position, which will turn on the vehicle. The dash will then enter its startup phase, and you can see a pre-charge indication here. Once the bus has completed pre-charge, it will go into its drive mode, given that the ignition switches are turned. If you then look at the dash, we have various things such as a temperature gauge, a speedometer with a gear indicator. We then have a power gauge, which will show the real-time power and torque. You have a state of charge gauge as well, which will read from 100 to 0, and your standard odometer reading. We also have short-term and long-term efficiency indicators. So this will tell your instantaneous efficiency, so it'll change rapidly if you're going up a hill, and your long-term efficiency trim over the course of the current trip. You'll also have an estimated range remaining, as well as a trip indicator for how far you've traveled since turning on the vehicle. We have additional screens available to us, so if I hit the button, you will see our charging screen, and this will automatically come up whenever you plug a charger into the vehicle. In addition, the driver has a keypad accessible to them for accessing different drive modes. So if we engage the brake pedal and press the drive button, the vehicle will engage the drive gear. This is indicated on our screen by the 1 gear, and this vehicle has a 2-speed gearbox, so it will self-engage second gear at a high enough speed and the gear will change to number 2. If we jump into neutral and then reverse, you can hear our reverse beacon going off and our gear indicating 14 for reverse. back into neutral, and you will see that the throttle map has been disengaged, so there will be no movement to the bus when the throttle is pressed. To turn off the bus, you simply just have to remove the key, the display will shut down, the bus will discharge, and you're all good to step out of the vehicle. This is the low voltage setup on our EV converted double-decker bus. So we have a 300 amp hour 24 volt battery connected to a solar system on the roof. So that solar system includes a smart charge controller, distributor, and BMS, and that allows the solar panels on the roof to charge up this 300 amp hour low voltage battery. So this will be used for things such as the refrigerator, for a stovetop, for lighting, and any other 24 volt components within the bus. So this battery is also able to be charged by our start battery. So that means while the bus is driving and the DC-DC is operating, it will charge this battery so that wherever a customer wants to pull up, it'll have a full lithium battery ready to use all of his home devices.